This is one of those you might want to be able to go back and watch this session again on Revit custom components. So again, to model those columns, what I had done was component, model in place. Again, when you're learning this content, we're using generic models. We're using the extrusion. So an extrusion, easiest way to model something like a column is just to start with a box. And I believe we were, oh dear, 1 by 10. Right? So those were the outer perimeters on the column. The next thing that I did with that was inset everything 1 inch to set up the thickness of the I-beam, drawing a center line, offsetting that center line 0.5 inches this way and that way, and then a lot of splitting, 1, 2, 3, 4, and a lot of trimming. And again, this isn't the way you'll always do I-beams in the future or W sections in the future, because there are preloaded ones, but for right now, as you're learning this content, this is how I want you modeling them. Okay, I don't want you using the button to bring in an I-beam. You'll have more design control over this as a system than the pre-built structural components. Okay, so this is how I want you modeling this content, right? So pretty easy and pretty fast to do, especially when you're working on a project and you're going to have multiples of those to push and move around, right? So that was created, when that was built, that was created on the level 1 ground plane, right? So if I select this and go back to edit extrusion, these purplish lines live on the level 1 ground plane. And I know that if I start drawing, I'm going to be able to see, let's go to level 1. Right, come on. If I'm on level 1, if I'm drawing, everything that I'm drawing exists in plan view, right? And that plan, as long as I am navigated, as long as I have navigated to level 1, my work plane or my reference plane is level 1. Okay, so super important concept to wrap your head around in Revit. Now, if I go to an elevation view like this, you can still see those lines, right? They're right here. But I want you to think conceptually about this. If I start drawing lines here in Revit, it's not going to let you. Okay? The reason why, it has no idea where you're wanting to draw. None. Zippo, zilch, nada. Because there is no 0 really in an elevation view. Right? So an elevation in Revit is still a section. So my east elevation, let's look at this in the floor plan view. If I go to level 1, let's just go ahead and finish a couple of these things out here so I can get my elevation tags. So this is my east elevation right here, this blue line. So that tag represents the east elevation. It's in by default. I can move that around if I need to change where my east elevation is based on my model. But if I click on that little triangle right there, it gives me a blue line. And that blue line is a section cut, looking in this direction, showing the east side of my model. So that is the east elevation. But if I think about standing and looking this direction, I don't have a reference plane. I don't have anything to draw lines on. Okay? So if I need to create something in elevation view with a custom component, I actually need to create something to draw those lines on. And the process of doing that's called creating a reference plane. And so you can think of a reference plane as a virtual piece of paper in your 3D model that I can draw on, right? So when I'm working in something like Format or SketchUp, those programs don't really care, right? You can just draw, it goes wherever. Hopefully it closes out, and hopefully you've done it right. But that's also why SketchUp and Format don't give you a super precise model all the time. That's why they can generate errors in terms of being watertight, in terms of coplanar faces, all of those issues that can pop up pretty easily. Revit's not going to let you do that. It forces you to model with a high level of precision. And defining, okay, this is where I'm going to draw it in 3D is part of that precision. So I have reference planes by default, and those are my floor plans, right? But anything else that I want to draw, I'm going to need to create a reference plane for. So for instance, let's open up the website for the Cliff House really quick. Cliff House, Cliff House, Cliff House. These beams right here. Those. The easiest way for me to draw those in would be looking at this elevation, right? So the same way that I drew the I shape for this column, it would be easiest for me to draw that I shape in elevation and sweep that back or extrude that back, right? So this is an instance where I would want to go into my drawing, create a reference plane, and draw that I-beam on the reference plane. So that's what we're going to cover today. And then we're going to push these columns to twin motion. Then you're going to have the rest of the day as a work day. And starting next week, we'll start to add in walls and windows. Cool? But we're starting with these sort of structural components first. Okay, so inside of Revit, let's delete that stuff. So I want to be able to draw a reference plane somewhere right around here to build those beams that intersect the columns here and here, okay? So I know that those are just to the inside, and if you also notice, that column happens to the inside edge of that I-beam column, or W-section column. I'm really not sure which it is. It looks more like an I-beam than a W-section. That's a good Keith question. And we're going to worry about the X-bracing as we get a little bit more advanced. We'll leave that for later, because that's an even trickier thing to do, because all of a sudden we're needing a reference plane on axis with that. Okay, so let's just worry about these right now and getting them tacked together, and let's get a floor in so that we're ready to start building on top of all this stuff. Okay, so inside of Revit, I'm going to go ahead and keep those beams running back in the same family as the columns that I already have. So I'm going to select those columns, and I'm going to go Edit in Place to open up that family. I know that I'm going to draw those from the north elevation, right? That's my north elevation right here. So if I look north, I've got the two columns. If I change my view to wireframe, I can even see the smaller columns running in the background, right? Here and here, those are the smaller columns a little further back. So what I'm going to do is, in my floor plan view, so I'm going to go to level 1, I'm going to go create. Before I start creating, I'm going to draw this virtual piece of paper in my floor plan view. So when I draw a reference plane, usually 9 times out of 10, I'm drawing that in a plan view. Okay, and it's this little tool right here. And that reference plane, you're essentially drawing a single line. And think of that single line as something that's going to represent a piece of paper that moves up from that vertical line in 3D space. So I'm going to show you exactly how that works, right? So I'm going to go reference plane, and I'm going to select right here along the edge of that wall, and I'm going to extend that out. If you notice one of the first prompts, it says click to name. I need to give that reference plane a name so that I can select it, right? If it doesn't have a name, can't select it. So I'm just going to call this North RP for reference plane. North RP. Pretty easy. No big deal. Okay, so let's look at that in 3D. This is, you don't need to navigate to 3D, but it's easiest to see what's happening if I show you how this is going to play out in 3D. Okay, so I'm going to go to Create, Extrusion, and I'm going to click Set Work Plane. Right now, my default work plane, if I look right here in my properties, is level 1. So it's still drawing on my floor plan. Okay, if I go to Set, right here, I have Specify New Work Plane. And since I gave that a name, North RP, I can select that reference plane and say, OK. Right next to Set is a little button called Show. And if I turn Show on, it will bring up a transparent blue piece of graph paper that shows me where that reference plane is. Now, do you understand that reference plane, just because it's that little bitty square here, it extends infinitely in all directions in that plane, right? So if I start drawing lines, I can draw lines way over here. And if I orbit around, you'll see it's putting those lines on that reference plane. Okay? Super, super important concept for you to wrap your head around in this. And I need those, again, I need those reference planes to be able to have precision. Cool? So let me go ahead. I'm going to delete those lines. There's two ways I can get to the north elevation now at this point. I can certainly go to my north view like that. And that's probably the most convenient because I know I want those beams at level 1 just below it. Right? So it's a really easy view for me to draw in as long as I have that reference plane in place. So from here, I'm going to draw that Ibeam out. Okay, so I'm going to start inside edge of my beams. Click. Depth. We've got to guess a depth on these. Let's see here. They're pretty chunky. What do y'all think? 18 inches? 2 feet? 24 inches? We've got to vote for 24 inches. All opposed? All in favor? 24 inches. No one's opposed, no one's in favor. So we're going 24 inches. So let's go down 2 feet. Across. So again, I'm boxing that out. Right? I'm going to run my offsets. 1 inch. Oh, I really should do top and bottom, not just on the side. Center line to center line. Offset. 1/2 inch. To make the flange. And delete the center line. Right? It's the same process that I was making those in terms of columns. And now I'm ready to run the splits to divide the lines up. And then trim to put everything together. Okay. So I now have that eye shape drawn on that reference plane. Okay. From here, I know this is going to go 12 feet away from my reference plane. And to be honest, I never remember exactly which way it's going to go. So it's either going to go 12 feet this direction or 12 feet this direction. Because of karma, it's probably going to go exactly where I don't want it to go. right? So let's green checkbox it, and it did. It went exactly where I didn't want it to go. Okay, but now that I have that established, it's pretty easy for me to start working this in plan view. So if I go to my level 1 floor plan, I should be able to see where that beam is. And actually, I can't. Let's go to wireframe. Oh, and I've run into a really fun problem. Not a bad problem, just a problem. So I'm going to go ahead and say finish sketch. Oh, there it is. That's weird. I guess we did fix that the other day in terms of establishing our level 1 view so that we could see down. Do you guys remember doing that? Okay. From here, what I'm going to do is I'm going to use the grips and pull this extrusion approximately where I need it to go, which it is going to come back all the way to the end of this, and it is going to begin right there on that reference plane. Okay, so I'm simply using these little widgets to push and pull that form. Now, those are something I was not able to use with a whole lot of precision. I don't really know where those are at, right? So if I select this again, just select that, and I'm going to go edit in place. And let's look at that extrusion again really quick here. I'm going to select that. And if you notice, I've got these sort of arbitrary numbers. 125, 128 of an inch. So no, it's just off the reference plane. Much smarter to go ahead and set that to 0. Do y'all remember how long the house was? 42. So I can go minus 42 feet. And I just locked in an accurate dimension on that beam. So it should be starting now exactly at 0 on my reference plane, into the outside wall, ending 42 feet or minus 42 feet away from the reference plane at the other end. Okay, so if you'll notice, Revit is going to do some weird stuff. And this is 3D modeling here, y'all. I mean, this is just one of those things that's going to happen. You see how there's not a line right here? Where this beam is passing through this column. Right? That is something that in terms of when we send this to Twinmotion and do renderings, it will not matter at all. Twinmotion could care less. Revit does. Revit is not going to show a line there because it doesn't know that there should be a line there, right? So right now, those are two independent things. They don't know that they're touching each other. So the really simple way to fix that is to just join them together. I'm going to merge those two objects together. And some software platforms, this would be a permanent marriage between these two things. The only way to get rid of it would be to undo it forever, right? Revit doesn't really care. It's just going to make this a temporary thing to say, okay, those two objects are connected. So I'm going to go join. This beam is joined to that column. Now those two objects look like they belong together, right? So I see this line right here now, and I also see that line where the flange intersects the flange of the other column. Super important step to remember to do in this. Cool? So there's two of those, right? So I need to be able to go to my top view, and I can select this beam right here, and I'm going to go copy. But this time I really want to copy this with some precision. So to do this with some precision, I'm going to copy that endpoint right here on this column, and I'm going to slide that over and attach it right there. Also, you'll notice these no longer look right. So I am going to move those. Move. That should be over here. I'm going to have to remodel those because that doesn't look very good either. But we'll fix those at a later date. But I know they shouldn't be hanging out to the side, right? So if I look at those in 3D now, oh, I am in 3D. I need to join these two together again, because again, I have that little A right there, so I'm going to go join this column, that beam, and we have a lot of stuff together now. So let's add one more thing in. I want to go to my north elevation, and I want to add in a floor plate. Okay? So once we get to floors, there's really no good reason to not start using Revit, the Revit modeling objects. So there is a floor tool. And with said floor tool, I'll have a lot of additional options in terms of how Revit functions. So that's where I stop using generic components on something like a floor. Okay, so if I go to the level 1 floor plan, I can go to, oh, I need to exit the family first, right? So I'm going to go Finish Model. So now all those beams and columns are a single family. And I'm now back to working on my primary Revit model. So at this point, I can go to Architecture, Floor. So this is going to bring up the default Revit floor. It is 12 inches thick. So that is basically a floor system. You can think of it as a solid chunk of concrete, but it's not. It really doesn't know what it is. But it is 12 inches. That's going to represent the finished floor, and it's going to represent the structure within the floor system, right? So it's a 12-inch thick floor system. And I am going to start by drawing that. I know it's going to line up with the end of those beams. So we're going to line up edge to edge, and I know I'm probably going to need to fix this width. It's going to be an arbitrary width, but we'll fix that in just a minute. I know this line goes 42 feet that direction. This line, it looks like it should be 15 feet. And then I'm going to connect that together. It looks like 15 feet is just a bit shy. So I'm drawing that at 15 feet, 2 inches, right? So I can check those dimensions anytime that I'm drawing. Like if I just select one line in my floor, right? If I select this edge, again, it's going to give me these temporary dimensions. 15.2. And again, Revit is really friendly about pushing things around for you, right? So if that needed to be 15 and not 15.2, if I could just select, retype in 15, it's going to change the dimension, where that wall is located. If I want that back to 15.2, 15 space 2, and it's going to push that around, okay? So I basically have that floor outlined. And again, think about what we were talking about in Revit. I'm drawing this on my level 1 floor plan. That is a series of purple lines that's going to define that floor system. When I green checkbox, it's going to create the floor. 12 inches thick. And if you notice, it is going to project down from level 1. Because that's what floors do. We usually don't define the floor, like what we're standing on right now, this carpet, we would define that as level 1. We wouldn't project the floor up into that, right? So a floor system in Revit is always going to be drawn on your floor plane, your level 1 floor plane, and it's going to project down whatever the thickness is. So if I look at my north elevation, I notice I have one more edit that I need to make. Location of these beams right here need to drop down by 1 foot because they are going underneath, not through the floor. If we go back to look at the image on the website, that entire beam is running underneath the floor. Go with me? Cool? So let's go back into Revit. I'm going to select that family, edit in place. Super easy to do. Beam number 1, move. And let's move it down. Beam number 2, move. Move it down. Easy peasy done. If I look at what I've got in 3D, I'm going to go ahead and finish the family. Look at that in 3D. You can see I'm starting to get that to look like the starting point of that. Right? Cool. So let's push that to twin motion, and then I'm going to give you guys time to work, finish this up, and ask questions. So from Revit, I need to do one very key, very important thing with these generic families. Okay? Right now, they do not have a material, well, they do have a material assigned. The material assigned is called default. And I need to tell it that is a metal, right? So I'm going to call it structural steel. So I need to define all of those beams and columns as having the same material, and I need to do that inside of that family editor, okay? And I want to do that before I send it to Twin. You will forget to do this on a regular basis. I forget to do this on a regular basis, but I'll be showing you how to update your Twin Motion file after you've assigned some materials and not others. Okay, it's a pretty easy thing to do. So I'm going to select that family again. I'm going to go to Edit in Place, and I'm going to select all of them. So one big lasso around everybody. So that means this Properties panel is now the property for all of that geometry. If I am not in the family editor, that data will not show up over here. So I have to select it and hit Edit in Place first. I have to be editing my family for the materials to show up. So I'm going to select everybody. I'm going to go down to Materials, and it's going to say just by category. That means nothing has been assigned to it yet for materials. I'm going to select that, and I'm going to see these 3 little dots. 3 little dots is your universal sign in a program for more options. That's what it means. Okay, so 3 dots, the ellipses. I'm going to click that, and it's going to pull up my material editor in Revit. I'm going to come down and click the little plus sign, create new material. I'm going to right click on that and say rename. Structural steel. That simple. Okay, I could go ahead and define its materials in Revit, and we'll get there, but for right now I just need it to have a name, so that when I send this to Twin Motion, it also has a name. Okay, so given that, I can say okay. I can finish the model. If I look at my floor, this generic floor, and go to Edit Type, structural material is also by category. Right, so let me back that up and let's give it a material as well. So I'm going to select it, Edit Type, and your materials on a default Revit system, walls, roofs, floor, it's defined as the structure. It's going to be in your structural tab. Because again, the material, whether it's wood or concrete or steel, it's going to define its structural and thermal performance. Right, so under structure, I can click Edit. Right here, I'm going to see material by category. Same thing, create new material, rename, floor. Okay, okay, and okay. So I now have those 2 things defined. Floor material, structural steel material. Now, if you go through Twin Motion, you can install and plug in that now there's like a single button that will open this up into Twin Motion. And if your computer can handle it, great. I'm not going to teach you how to use it though, because a lot of times laptops especially are really notorious for crashing, because essentially to have that sort of automated connection to work between Revit and Twinmotion, I have 3 really heavy programs running. I have Revit running, I have Twinmotion running, and then I have the software that's making those 2 pieces of software talk to each other. The advantage of that is if I make a change in Revit, it's going to automatically update Twinmotion. The disadvantage is the high potential for a crash, unless you have a very, very powerful computer. So I teach a slightly different method of getting these things to Revit that's going to be more reliable and more stable for the average laptop. Okay? So what we're going to do is in a 3D view, very important. I have to be in a 3D view. If I'm in a 2D view, it's only going to export 2-dimensional data. So I'm in a 3D view. Yeah, I do want to save the project. Thanks, Revit. In a 3D view, I'm going to go File, Export, and we are going to use the FBX format, right? This is actually the second time we've gone through this one. Did the same thing with the site topography. So we're going to go Export, FBX. And for right now, I'm just going to write this to my desktop, and I'm going to leave it named Cliff House. So it's a 2015 FBX file, which is short for film box. So I'm going to go Export and Save. Then I'm going to go ahead and open up Twin. First thing, remember we read Twin top down in our workflow. So very top thing, I'm going to import, open. That was on my desktop. Cliffhouse FBX, open. I'm going to accept those defaults. And as we learned, do not import this as a landscape. Weird things happen when you do that. We think it's a cool new feature. We haven't really fleshed out exactly what happens. We're importing geometry. So we're importing geometry, Cliff House. We are going to keep the defaults and say import. I can select Cliff House from my list. Hit the F button, and there's Cliff House. Looks like I need to raise it up just a bit because it came in at zeros. Let's go to the sunny side. And now I'm ready to go materials, metals, and I'm just going to drop a basic steel, which I think is probably just this brushed aluminum is probably going to be the easiest one to edit as I go along. So I'm going to drop that basic steel on there, or brushed aluminum, because I can take that and let's just make it just a bit darker. That. And then this flooring system, I'm going to need to work with it quite a bit, but I know it's going to start as kind of a wood system. Scale it up so it looks a little more correct. And I'm up and working. Cool, so that's where I want to try and get everybody through today. Alrighty. So, let's do that.